What I want to do in my talk is firstly give an overview of the Marne project and talk about what we've been doing and some of the outputs from the project. And then I'm going to specifically talk a little bit about one of the activities that we were involved in, which was looking at the way the directive on sustainable or strategic environmental assessment has been carried out in the different partner countries and look at that process. I guess what I want to talk about in terms of the project itself is who we are, why we got together, and some of the deliverables that we've managed to pull together over the last couple of years. The project is being led by Cardiff University, and then we have 4 other partners, as you see here, from Ireland, France and Portugal. And the reason this grouping got together is because we have different skills within the marine environment area, marine renewable energy area. And if you look at the lead partners, such as Cardiff University, amongst other areas, they are world leaders in terms of assessing and developing tidal barrages and tidal lagoons. We've worked quite a lot over the last number of years on different processes in the marine environment, but particularly with respect to this project on tidal stream energy. Our colleagues in IH Cantabria have expertise in offshore wind engineering. The Instituto Superior Técnico in Lisbon have expertise in wave energy. And in the lab, the IFREMER lab in Dinard, they're not engineers, but that's okay. They have a lot of experience in terms of assessing the environmental impacts of marine renewable energy. And we're very lucky to have this group because they're very closely associated with the Laurence barrage, tidal barrage in Dinard in the north of France. This is the world's first large-scale commercial tidal energy converter. It was built, I think, in 1966 and operates to this day. And if you're in that part of the world, there is a motorway across it and you can drive across this barrage. And it's an engineer's holiday. It's very sad, but these are the things that some engineers do on holidays. You drive over it and you get excited by these things. And we're also lucky, having all the partners, but just extending that theme in terms of barrages. The Cardiff University group have spent many years and are still working on promoting and hopefully realizing the dream of a Severn barrage, which, as I'm showing a schematic of it here. I think this is about 10 miles long. The cost of this is somewhere in the order of between 20 to 30 billion pounds sterling. And the interesting thing about that is the investor money is available to construct this. The issues why it hasn't been constructed or why it's not been constructed, and these people will talk more about it than I will, is because of environmental concerns, and rightly so. Obviously, the environmental issues have to be addressed before a major infrastructure project like this gets built. But this is a major infrastructure within the marine renewable energy. So that's what the group and the different, some of the different expertise that brought together. 2 of the main foci of our project have been to develop tools and methodologies to optimize energy extraction potential. So how do we quantify the resource? And there has been a lot of work over the last 10 years quantifying marine renewable energy resources, and some of it has maybe not been so accurate. One of the things that will happen if you put a device, say a tidal turbine, in water, that changes the characteristics of the flow field. It changes the amount of energy that's available. So we've done a lot of work in this project in trying to more accurately determine potential resources. And the changes of these devices will also affect local environment, may affect local environment depending on the degree and the amount of devices you put in place. For example, if you put a lot of tidal turbines in the Shannon estuary, we have shown you can get severe flooding upstream of that. So one of the balances is to try to determine, well, what are the minimum number of devices that make economic sense and yet also make environmental sense? So there are some of the issues that we've been looking at in the project. We have a number of deliverables. One of them is, and you may say, a mandatory website, and I hope that my web connection is going to work here. I may just have to go out of this for a moment. No, it's not working. It's just after freezing my machine for some reason or other. Okay. We have a website, and this is the URL of that website. And on it, you can find reports. Actually, they're not all uploaded yet, but reports are being uploaded. For example, we have produced a series of reports, and I'm just showing you a selection here by the different partners. This is one produced by Cardiff University on investigations into the barrage. And these are a series of reports produced here at Galway, looking at, firstly, the potential for tidal energy at the Shannon Estuary. Then another one looking at the effects that tidal turbines will have on water levels, on flow fields, and also on the transport of pollutants within the estuary. And then our Portuguese colleagues have produced some other reports on looking at the potential for wave energy in a number of locations on the French coast. So I think in total at this stage, in fact, we have about 20 of these reports, all of these being made available on the website in due course and available for people to download. As part of the project, we've also developed and written scientific papers that have been produced in journals. And in fact, the proceedings from this conference will be published in a journal called Computers and Geosciences. So we have a number of publications already out there in the scientific domain. So just showing you a selection of these, and there are a lot more. We also developed, and I can't show you that either, we've developed a database, which I do want to show you. And this is it. This database is available on our website. And what we've done here, is my colleague Dr. Indy Olbert, who did most of the work on this, we have broken the marine renewable energy sector down into four components: tide, wave, wind, and barrage. So if you click on the title button here, what we've done is we've developed a database of information on various projects that are happening around the world within each specific domain. So we've got a device type, in this case with tidal turbine, horizontal axis turbines. We give information on the specific project. In this case, it's a project called CGen. We've got some information, summary information on that. We have a location where the project is, who developed it, stage of development, and websites and document references relating to the project. So we have done this for a lot of the tidal research projects that are going on around the world at the moment. And we've collated similar information on wave energy and also on the other two areas here, which are wind energy and barrage. So these are populated database. It's available for any of you or anybody to download, and we feel that this is a very useful place for people who are beginning or who want to collate information regarding marine renewable energy. You can take this database and you can add to this database as you wish and use it for your research. Also, as part of the website, which unfortunately I wasn't able to get onto because of the internet access here, we've got an online system, a Google Earth system, which shows you some of the results from the modelling studies that we've done live on Google Earth, and also a lot more of the reports behind the project, the MARIN project itself. And a lot of the case studies that we've been involved in will be described in more detail by the other presenters during the project. So that's an overview of what we've been about in Marin, where you can get information, and some of the reports that we've produced. Not all of the reports are finished, but I think we had a very good project partner meeting yesterday, and we know what's left to be done, and I think we can meet these deliverables. In terms of environmental regulation, what we looked at here were how strategic environmental assessments and EIAs are being carried out with respect to marine renewable energy. And obviously there is a linkage between both of these, and essentially the strategic environmental assessment is used to give a framework for specific environmental impact statements. The regulation, this regulation is essentially based on the directive, the EC Directive 2001/42/EC, and this is known as the SEA Directive, the Strategic Environmental Assessment Directive. And what it says, what this directive says is that we need to have published a strategic environmental assessment, and this is done at a high level, at a national level. We need a plan or a project, or when a plan or a project is likely to have significant environmental impacts. So what we know is that if you put a lot of tidal turbines in the Shannon Estuary at very high density, that will have a significant environmental impact. So in terms of planning a project, you need to be able to determine, well, what is the amount that you can put in a certain environment, making the project commercially viable, but also making sure that we minimize environmental impacts. So we need an SEIA for that. And we then use the SEIA to set the framework of the detailed environmental impact assessment. And I'll talk a little bit just about that interaction in a moment. Just again to talk about the difference between SEA and EIA. In both, basically, what you will see here is we've got SEA at the top and EIA at the bottom. And by and large, what you see is SEA is done at a high level. For example, if we look at the level of uncertainty, so we are, say, nationally saying we're going to designate certain areas where we are going to allow tidal turbines to be deployed. On foot of the SEA, what's the uncertainty level associated with that? The level, it's accepted that the level of uncertainty here can be high. We can have a high level of uncertainty based on the SEA. Once we go to a detailed farm within the area where we're allowed to put farms, we then have to have an environmental impact assessment for that specific farm, and the level of uncertainty now should be very low. We should be very sure that when we put this farm in place, that the environmental impacts will not be significant and that we can quantify that. So the level of detail associated with an SEA is generally quite low. It's broad brush in a sense, whereas the level of detail associated with environmental impact must be high. And if you look at the different stages associated with carrying out SEA or EAI, these are the various stages. You will see that it's well documented that each of these stages needs to be addressed at a different level, both in SEA and EAI. So when you come to implementing a directive such as SEA, what tends to happen is that the European Commission does not say this is how you implement it specifically country by country. So each country interprets it differently, and we then develop different SEA methodologies. So if we look at what happened here in Ireland, the Sustainable Energy Authority of Ireland, SEAI, have published at this stage our SEA with respect to marine renewable energy. This was after consultation, broad consultation with industry and with academia, with the public in general. Initially they presented a draft plan, then we had consultation was taken on board, and then we now have an SEA. They've published this in two manners. One is an extensive document which is nearly 500 pages, and the second is a non-technical summary. And the issues that are addressed, it may not be very clear here, but all of these notes are available to people after the conference. To look at the context that the Irish SEA was developed, and it was in a broader context of not just looking at the environment, but also looking at developing a plan for offshore marine renewable energy. So the SEA became part of a broader plan to develop environmental or marine renewable energy. And the plan sets out development scenarios in Ireland. So it doesn't say this is what it will be, but it gives different scenarios as to what the future might be like in these different areas. And one of the main guidance within this was that by 2020, the aspiration is that we would have this type of marine renewable energy feeding into our national grid, that we'd have 4,500 megawatts of offshore wind and 1,500 between wave and tidal. That's by 2020. It's ambitious. Whether we achieve it or not, we don't know. One of the largest power stations in Ireland is about 900 megawatts. So offshore wind is about 5 times the largest power station that we currently have feeding into our national grid. So this is substantial energy if it can be harnessed. The approach that was taken in Ireland was a three-pronged approach. One was a generic assessment, and this is basically non-spatial, nothing to do with specific location, but it was looking at how a particular device could affect the environment. So how might this particular device affect the environment? That was the first stage in the process. The second stage was in developing assessment areas. And what this means is that the coast and the offshore area was looked at from the point of view of saying, well, we think this region here is suitable for development of offshore wind, this region here is suitable for tidal, this region here is suitable for wave energy. So these are known as assessment areas. And the third part of the process is where you combine the effective device on the specific local region of the assessment area. And this is known as the cumulative assessment. So when you put this device now in this area, can we still go ahead with projects? So this is a typical framework as to how things happen. We first of all look at the technical resource. That is, what is the resource that's out there at the moment? So we can quantify that with our models. We can say that we get so many megawatts from wave energy, from tidal energy, etc. You then say, well, how much of this is constrained? Where are there pipelines? Where are there shipping lanes, etc.? So all of a sudden, these come out of the equation. So we've now got a constrained resource. You then look at the number of developments that you could have in an area, and then you look at the potential environmental impacts, and you look at the mitigation of those environmental impacts. And you eventually come up with a possible development potential and environmental effects. So in the Irish context, this map here shows us the assessment areas. So here we're looking at the different areas. For example, this is part of the Shannon Estuary, which is potentially suitable for deployment of tidal energy. So on top of that, what the evaluation does, what the assessment does, is it takes each of the assessment regions here, goes through a thorough, or at this level, a thorough environmental assessment, and comes out with the amount of different types of renewable energy that can be located in these particular specific locations. So this is, for example, how much fixed wind you may have, how much wave in different water depths, how much tidal, and how much floating wind. So this is where you would have maybe a monopile in shallow water, and this, the far end, is where you have a floating structure, a very complicated engineering device in deeper water. So from an Irish perspective, we feel that the SEA is quite a comprehensive document, and it covers all three main areas of marine renewable energy: wave, tide, and offshore wind. And it has now given us the sites that are possible for deployment of marine renewable energy, and it's highlighted likely environmental issues that need to be taken into account in detailed environmental impact assessment. Now, if we look at other countries, and although Scotland isn't a partner in this project, unfortunately, I guess, and I also just put a note here, in the UK, they have divided out the environmental, strategic environmental assessments in that Scotland has its own assessment done, and then England and Wales has its own assessment done separately. So the Scottish one, in fact, again, they've developed an SEA. This is a non-technical summary, just like the Irish one. Their approach seems quite similar to the Irish one. They have come up with assessment areas for wave and tidal. They have not looked at wind in this particular document. And as part of the cumulative process assessment, they have identified the assessment areas, such as the Western Isles, and then have talked about the potential for generation as to whether it's high or low in those areas. So it's a similar process to what we've done here in Ireland. And then they've developed a cumulative assessment, and what they've done here is they've taken a number of different scenarios, which I'm not going to go through, but I just want to show you the framework as to what they've done here. They've taken different scenarios, and then they've come out with the cumulative environmental impact of these various scenarios on the assessment areas. So in terms of comparing it to what's been done here, it's quite similar. It's a very comprehensive document. Coverage is a bit less, it's wave and tidal, and the assessment is very similar to what's been done here. Now, if we look at the rest of the UK, they've written quite a number of different SEAs. And I guess one of the big differences between what's been done in England and Wales relative to what we've done and the Scots have done is that the strategic assessment is not just pertaining to marine renewable energy, but it pertains to the broader offshore energy. So as you see here, this document is for offshore renewable energy, offshore oil and gas, hydrocarbon gas, etc. So they've looked at broader offshore energy rather than just specific marine renewables. Their assessment procedure is different. I'm not going to go through it. It's very detailed, very comprehensive. But the outcomes are similar, because here, if you see what they've done, no different to what we've done, is in this case for wave power, for tidal and for offshore wind, they've identified the area, they've identified the resource and the areas that those resources exist in. And then they developed again a cumulative assessment, so that they've taken the different areas such as southwest England, Wales, and they've in this case, they've identified the size of arrays that you might put in place there. They've done it a bit different to Scotland and to Ireland. What they've done here is, in fact, which is interesting, they've given you the footprint. Here it's about 0.5 of a kilometre square that will generate a certain amount of marine renewable energy. So they've done it in a little bit different area, but you can still get the same basic information in terms of knowing where the resource is and the amount of resource that you're likely to be able to extract from that, having minimum effect on the environment. So again, it's comprehensive. It looks at wave, wind and tidal, but within a broader context, and it's quite a detailed assessment. In Spain and Portugal, at the moment, they've got best practice guidelines, so they haven't developed full SEAs at national level. And looking at Spain, I'm not going to go through the list here, but they've identified the aims for strategic environmental assessment. Although they haven't one published, they've identified aims for that. And they've also mapped areas that are suitable and unsuitable for various installations. So again, developers can look at these regions and say, yes, it's likely in the future we can go here or we can go there. And again, Portugal is at a situation where it's developed best practice guidelines, but mainly relating to wave energy. So I guess in summary, there are major differences between some of the countries, and there's some high levels of similarity between other countries. And this is not unusual in terms of the way countries implement European directives. If we look at the Water Framework Directive, for example, we have quite a different approach to many other countries in Europe. At the end of the day, the objective there is to have good ecological status in our water. How we do it is our business in one sense, and the EU allow you to do that. So it's the same thing here with strategic environmental assessment. And at the end of the project, we've done a draft on this, but we will be publishing an inter-comparison of the different approaches so that people who are in the industry or who are interested in research will understand the difference of these assessments from the different countries. And I guess if you look at it from the point of view of Ireland, Scotland and the rest of the UK, we're actually quite similar. In each of these three cases, we've gone to the development of a full SCA, and the end product of each of these, in fact, although different and presented differently, is quite similar, and the amount of information that you can get from it to allow you to go on to the next stage is quite similar. So with that, I think I will leave it, and I think the idea is that we take questions for the two sessions at the end of the second session, because that's a longer session than this one. So thank you very much.